Hello, and welcome to the latest in the series of podcasts that Somerford Associates are doing across a broad range of subjects. This week, we are looking at Splunk Observability and continuing the theme of observability that we have been running over the last few weeks and plan to do for at least another few weeks with Splunk, our largest partner. And today I'm joined by one of my colleagues and one of our Splunk colleagues. Firstly, I've got Dan Gray, who's one of our technical consultants from Somerford Associates. Hi, Dan.
Hi, John. Nice to meet you.
Excellent. Good to see you as well. And Robert Castley, a senior Splunk observability strategist. Robert, welcome.
Thank you, John. Thanks for having me.
Good to have you here. And thanks again for your consistent support. So we're going to kick off a nice easy one for you both then. Observability. Dan, in layman's terms, please tell me, what is it?
Observability. What a philosophical question. Observability is trying to understand what's going on inside something by measuring the things that are coming out of it. So if you think about a server, for example, or an application, we want to measure what's going on inside that application by seeing the metrics that are coming out from inside.
Okay, and why is that important, though?
So if we can understand what's going on inside, we can understand what's going wrong with it, or hopefully what's going right with it, and we can improve and iterate on our application or server. We can continually improve it if we understand how it's working.
Robert, do you agree with that?
Yeah, I mean, observability, it's a recognized term these days, and everybody's striving to be observant of their infrastructure, whether that's on-prem, whether that's in the cloud. When you're running across disparate resources, being able to collect that data and being able to visualize it in a single place, we're talking about people that run tens of thousands of servers, for example, that are hosting hundreds of applications. Can you just imagine that minefield of trying to understand what is going on in there and having the ability to observe those environments and to be able to bubble up the critical information about what's going right and also what could potentially be going wrong is absolutely critical to keeping these platforms running.
Oh, I see. Okay. So it's all about making some sense of some fairly complex environments, essentially.
Yeah,
that's what we're trying to do.
Everything has got more complex. With the adoption of cloud-based services. If you think about things, and I can spin you acronyms like S3, ECS, EC2, EKS, GKE, all these wonderful environments that are hosted in the cloud have broken up the way things were architected historically, like on end-tier applications.
Right.
And, you need to be able to understand, what's happening to my S3 buckets, what's happening to my Kafka, what's happening to my MongoDB, what's happening to my server it's all running on. Being able to collate that all together and paint a picture and understand how all the bits are joining together and the way that the data is shifting through these environments, and ultimately, how is it impacting the end user of the given application?
I see. Okay. So what would traditionally be drive an organization's desire to sort of push an observability platform? What are the sort of key business drivers for implementation programs for observability?
SLOs and SLAs.
Yeah. Gone are the days where it's like a single monolithic application. Today, they could be cloud-based or on-prem or hybrid, and it will be a series of microservices that all interact in complex ways. In order to meet those SLAs and SLOs, you need to understand where the microservices might be failing or where they might be running slowly. So in order to meet the business outcomes, you need to understand how all these microservices are interacting, and therefore how you can keep your uptime to an acceptable level.
Oh, I see. Okay. And so what in your experience, Robert, what are the main challenges that you've seen in implementation programs?
That all depends on, what environments you're going into. I mean, obviously with observability tools that are available today, if I take, the birth of Splunk Observability, which all started back with SignalFX, which was founded in 2015. That was actually in the same year that Docker was launched. So SignalFX, they built this platform to monitor containerized environments. And then obviously with the adoption of Kubernetes, an orchestrator for containers, that's kind of exploded. That said, you read in the press, you read all the news articles these days, you are seeing a shift of people going back to VM, in-house hosted solutions. They're still complex systems. They still need to be observed.
From the technical perspective of implementing Splunk Observability or using OTel collectors to collect your data, Splunk have done everything they can to help you do it. So within Splunk Observability Cloud, there's a number of wizards and GUIs that will take you through all the steps you need to do to install an OTel collector in your environment. And they support, dozens of different technologies, maybe even more.
Yeah, I mean, the integrations are in the platform. They stem all the way from, your basic host, where you're just going to collect host metrics, CPU, disk, network, etc., all the way up to instrumenting, complex applications, written in Java, Golang, PHP, Python, etc., and understanding the application performance of those applications written.
Okay. And you mentioned OTel, so Open Telemetry. Open Telemetry advancements. Can you just talk a bit about some of the key developments there have been in recent times in this sort of OTel world?
Yeah, so if we just sort of set the scene first, so the OTel collector or the Open Telemetry collector is an open source based collector that Splunk was already one of the largest contributors to, or were the largest contributor to the project. Since they've been bought by Cisco were also a large contributor to that. So now Splunk Cisco are by far and away the leading contributor to that. Which means that there's a Splunk specific fork of the OTel collector. So if you wanted to use it, you can go and download the Splunk specific one, and it will already be configured. In terms of the development, I'm going to hand that over to Robert. But what I would say is that Splunk are committed to using the OTel collector. They've said that that's their preferred way of collecting things. And from our perspective, we know that customers like that. The OTel collector allows them to keep control of their data. They're not having to download proprietary agents from all different vendors, so you can avoid like vendor lock-in. And yeah, because of its open source nature, it's really flexible, and it lets the customer keep control of their own data.
No, I see. Anything else to add to that?
Yeah, so there are two streams of OTel collector, or the OTel package altogether, is that there is what we call contrib or upstream, which is the development from the actual project itself. Okay. The project itself is the second largest project in the CNCF behind Kubernetes. So it's got massive gathering and a massive following now. We are still, one of the founders of the Open Telemetry project still works for us at Splunk. Okay. And like Dan said, Splunk is a major contributor to the project itself. It's also donated some key technologies to the project. Okay. And more recently, we're going to be looking at donating our profiling capabilities, so that's CPU and memory profiling. And we are looking to, whilst we have our own distribution today, we're looking to become more in parity with the upstream. And one of the examples of that is that today our real user monitoring offering is using our own SDKs to do that. But there is also development effort going on in the Open Telemetry project to further broaden the real user monitoring capabilities native to the project, and we will be adopting that. So we're moving ever closer to having parity with the upstream distribution.
I see. And you mentioned about donating stuff. I mean, what are the advantages of doing that then?
It's an open source project, and that's the way that.
So you're building a community almost, and you're getting collective buy-in.
There are other companies out there that have also donated some of their technology to the Open Telemetry project, in and around the logging side of the project, for example. So yeah, it's these donations from these companies that are really helping Open Telemetry become the de facto standard.
And sort of, I was going to say, and then driving advancements, I guess, all along.
Yeah.
So, Now, you both talked a lot about Splunk. I'm keen to understand why or who or what is it that separates the Splunk observability tooling from the rest, if I'm honest. I mean, this isn't a sales pitch at all, but what separates them from the rest? Because I'm sure there are loads out there all trying to compete in this space. So what in your opinion, Robert, are the sort of main advantages?
Well, I'm going to be biased, aren't I?
Inevitably.
Yeah,
Inevitably.
so I'll pass to Dan first, and then I'll let Dan bounce back to me.
Yeah, that's fair. I can tell you what I like about it. So, Splunk Observability Cloud, you've got your metrics, your events, your logs, and your traces, all going into one place. It genuinely gives you like full end-to-end visibility of your entire environment. And one of the key points that I really like, if you have a component that's not being actively monitored, it can identify that as an inferred service. So even if you don't have a collector on a machine or an application, it will know that there's something there, and it can give you, it can indicate if there might be a problem in one of these inferred services. So it's really clever. I really love it. From the user perspective and the user experience, there's been a lot of work done recently. It's really user-friendly. You can get everything that you need to in basically one place. There's been a lot of work done with integrations through Log Observer Connect. So if you have a problem in your environment, the full time to identifying and even resolving the problem is really cut down by using Splunk Observability Cloud.
I think you've done a good job of selling it there.
Yeah.
I mean, if we go under the covers of the actual way that this platform has been built, there are some key advantages to using the platform. One of them is the real-time streaming capabilities of the data. And what I mean by that is that from the point of ingest, so a data point hitting our ingest, to the point that it appears on the right-hand side of a chart is about 1.5 seconds. Okay. So in the world of containers and orchestration, etc., things live and die very quickly. And being able to detect something in a very short space of time is absolutely critical, mission critical, in those environments. On top of that, with the application performance and part of our real user monitoring capabilities is the full fidelity model. So we don't miss a single beat. So that means that we're not sampling data. Because if you're going to sample data, if you can imagine over an hour's window, you're going to have blind spots in your data. Things can happen in those blind spots that you will never capture or potentially never see. Having that full fidelity model means you're always going to have eyes on what is going on.
Okay.
Yeah, one of the big challenges that our customers talk about is not having that full end-to-end visibility, having those blind spots in data, not if something goes wrong, not being able to see what's happening.
And that sort of goes back to what we were saying at the beginning, isn't it? The business benefits to this, to be able to minimize downtime, and save resources, and presumably, it's far more cost effective as well.
Yeah.
And what about scalability? Is it something that is specific for large, small? Is it scalable?
So if you're talking about Splunk Observability Cloud, absolutely, it's a SaaS platform. So it's designed to meet the demands. I mean, it's a multi-tenant solution. So, as we see demand increase, we will then obviously scale the platform to handle those demands. If I think about, I know about certain customers, for example, that will absolutely rip down 150,000 containers a day and spin 150,000 back up. I mean, if you can think about, the cardinality of the data coming out of that kind of environment, it's huge.
It's a lot,
And they're not the only customer. No. So
yeah, when you say scalability, the buzzword brings you to these containerized solutions, and it didn't surprise me that this Splunk Observability Cloud was built with those in mind, because from a user perspective, it's really obvious. You can really drill into your Kubernetes clusters. You can see it. You can tell that it's been designed around these sort of ephemeral infrastructure. The other thing on scalability, coming from a slightly different angle, it's really scalable in terms of user base. So within Splunk Observability Cloud, there's like a team structure. So whether you're a single person who's charged with monitoring your infrastructure, or you have lots of people working on it, there's within the tool there's a way to design to designate people into different teams. So it's scalable in that manner. So whether you're on your own or you've got a large team, it's quite user friendly and easy to work with.
All right. Okay. I'd like to sort of move on, if I can, over to it's an acronym I heard recently, and as someone who's as an ex-army, I'm used to acronyms all the time. But MELT, metrics, events, logs, and traces. Mm-hmm. They're pillars of observability, which sounds magnificent, I have to say. But and I guess what I'd like to understand then is, and it's sort of going back to what you were just talking about a minute ago about the variety of platforms that whether it's on-prem, in cloud, or Kubernetes or whatever. How do all of those pillars contribute to achieving full fidelity, end-to-end visibility across platforms?
So, if we start at the very beginning, metrics, your first pillar. Metrics will always let you know you have a problem. Mm-hmm. It's literally binary. Is it on? Is it off? So being flagged that you've got a problem, your next part of your investigation is understanding where is the problem. And that's where application performance monitoring comes in through the tracing capabilities. Mm-hmm. One of the key things of the Splunk Observability platform is that the traces that we collect, the full fidelity model that we operate, we're able to automatically generate red metrics, so rate, error, and duration. And we will build out service-centric views using those metrics to easily highlight to you, okay, we've seen a metric, we've got a problem.
Yeah, and it really is very easy to see from the user perspective. You're looking at a map of different nodes, and if there's a problem, it's there.
Sticks out really
like
does.
a sore thumb. It's big. Yeah.
So once you've then sort of like start looking at your red metrics, and you can correlate your red metrics with your infrastructure metrics, you can quickly and easily see in that view, okay, is this error rate, is this latency, these duration metrics, are they caused by the infrastructure, the underlying infrastructure? So you can look at pod utilization and stuff like that. And, if it doesn't belong there, then the next part of your journey is your events and logs. And they're going to tell you what the problem is. Mm-hmm. So metrics, traces, and logs. Metrics, you've got a problem. Tracing, where is your problem? And logs, what is your problem? Now, that doesn't mean that logs will always answer the problem. You might get the answer once you hit the tracing aspect.
Yeah.
But, if you've instrumented your application and you've got your logging, useful information, it's very quick and easy to be able to troubleshoot that.
Right, okay.
And with the advancement of AI and ML, it's getting even easier.
Oh, yeah.
Okay, I was going to come on to that then. So how is the observability platform using AI and ML to sort of push stuff forward, make advancements in this capability? Because I suspect, I won't need to say to you two, but you can't go online these days or turn the TV on without someone mentioning it, or go to a forum in some shape or form. Mm-hmm. It would be remiss of me not to sort of have a conversation about that. How is it being used?
Well, I find it. Well, I was actually having a joke with some work colleagues. I've been in this observability space, and I've been a sales engineer for way too many years than I'm going to admit in this podcast. But it's quite funny if I think back to when I started out and I went on demo trainings, how to deliver, great demos, etc. You rock up to a customer and you spend 25 minutes, showcasing your product and demonstrating some of the key features and capabilities. With the advancement of AI and ML and what we have in private preview in Splunk Observability Cloud today, it's kind of quite funny because I can actually just type a question in and my demo is over in about 30 seconds because it's found the answer to the problem.
Absolutely.
So you're becoming redundant now.
I am.
Yeah, and me too. Because genuinely, if you could ask it a question: why is there a problem with my payment service? In human natural language, you don't need to know any coding. You don't need to know how to interact with the platform. You just type your question out in human natural language, and it will bring you back the answer. So it's remarkable. The other thing to say is, like, Splunk's been doing machine learning for years. Right. This is not a new thing for Splunk. They've been using machine learning for a long time, so it's very familiar to them.
And what's on the horizon then for it? What do you see? Where do you see it all going?
Well, obviously, with any of these sort of like AI engines, these LLMs, these large language models, they need to learn, and they're going to need to learn to understand your environment. So every customer that embarks on this AI ML journey, there is going to be some training as it learns, as it needs to understand, what is being ingested into the platform, because nobody's running identical platforms and applications and everything like that. So, there will be, aspects of it slowly beginning to learn your environment. And, as with all of this AI technology, it's just going to get better and better. But that said, it is still not foolproof.
No.
So there will always need to be that watchful eye.
That Mark 1 eyeball in
there.
Exactly.
At some point.
Excellent.
But that aspect of it, learning your environment, that puts it over and above any of the ones like the public ChatGPT sort of things. You can ask those things questions, but Splunk and Splunk Observability Cloud has access to your data. It can learn specifically from your data. So it will perform better than your average LLM that's out there on the internet.
Yeah, it's fascinating, really. So I'm going to sort of go back a bit now, and we sort of kicked off earlier on talking about some of the implementation programs and challenges. What are a lot of organizations and customers will clearly be keen to understand pitfalls about implementation and stuff like that. You've been through this loads of time. What have you seen where the key challenges are, and how are they often overcome?
So, key challenges, we could be rocking up to a prospect that's already invested in OpenTelemetry, and they've gone and used the upstream version.
Okay.
So one of the key challenges is making sure that whatever they've configured and instrumented, etc., we're able to get it coming back into Splunk Observability Cloud, and in the format, not a format, but that we understand it so we can visualize all the data for them. So, but like I said, because we're aiming to be more on parity with the upstream project, this is getting easier and easier and easier. Historically, yes, it was it could be a little
bit more challenging.
However, if you roll with the Splunk distribution, then it can easily be rolled out. On scale. Ansible, Chef, Puppet. These automation tools provide for easy deployment. Combine that with a little splash of Terraform and start doing what we call monitoring as code. It means that you can easily adapt, and if you need to make changes to your environment, you've got it in code. The code can be in a repo, it's versioned, it's controlled, etc. Then, through one of your pipelines, should you need to make changes, it's very easy to roll out, these changes, using the automation tools with a little splash of, like I say, Terraform to go with it.
All right, okay.
I'm glad you said that, because when you asked the question of the challenges, I was really struggling to think of them. I love the troubleshooting guide once you deploy the hotel collector. It basically comes down to, this can't possibly go wrong. There's something else wrong, and it's not the hotel collector. So it really is straightforward to deploy.
And there's some great open source tools out there that really can help with configuration, etc. One of my favorite projects is a project called hotelbin.io. And here you can basically take your hotel configuration, copy and paste it into hotelbin.io, and it draws a really beautiful graphical representation of all your receivers, your processors, your exporters, your pipelines, and it just gives you a lovely visual picture of what you're about to unleash.
Yeah, it's a really useful tool to use if you're learning how to deploy an hotel collector.
Sounds fascinating. And what about...
Check it out.
Yeah, I'm sure you'll be on there tonight, John.
I was going to just continue in that sort of theme about learning from best practice and all the rest of it. And what about setting up effective monitoring and alerting? What would your advice be for best practice for that?
So you need to first understand the data that's coming in.
Yeah.
Again, as we've discussed a couple of times already, no two environments are going to be the same. I would argue today the value of alerting on things like CPU and memory, etc., especially when you're in a cloud-based environment. You are renting space in the cloud and you expect it to provide resource, etc. I think where people need to sort of like think about their alerting, it's really going to come down to what it is that they see as critical within their infrastructure. Is it the message queue? If that starts backing up, we could potentially have a problem. Is it in our front end? Is it that we want really good user experience, or do we care about our search engine rankings? It can be anywhere in that infrastructure. One of the things that you don't want is alert fatigue and alert noise.
Yeah.
So with every journey, with every customer we go on, it's understanding the data that's in there and trying to reduce, that alert storm.
Noise.
And there's a great feature within the observability platform itself where you can do a pre-flight check on any of these. We call them detectors. And what you can do is you can look at some historical data. Now, obviously, it's not predicting the future, but you can look at historical data and see how much noise is created depending upon the configuration that you've done, on your detector. So say you set a static threshold and alert me if it goes over 85%, you can look at an historical window and it will do a pre-flight check on that data and will say, based upon that, it might fire 85,000 times.
Yeah.
Okay.
Because you're constantly up there.
Yeah.
But then then that you need to tune that detector to reduce the number of potential alerts that are being fired. And that saves a lot of time.
And effort. Absolutely.
Those pre-flight checks are really helpful to drive the conversation with a customer. If you ask them what they want to alert upon, they just come back and say everything. And a lot of the battle is to reduce the number of alerts down to just the ones.
I was just going to say, it takes them a while then to get to a point where they say, "Well, hang on a minute, we're just getting so much." Because that's, as you said, you get that sort of noise fatigue, and then all of a sudden alert fatigue, and all of a sudden there's a risk that you miss something that's important, presumably.
Yeah, absolutely. So we see alert fatigue all the time. So, as I said, the tendency is to put all the alerts on because you don't want to miss anything. You want to be alerted, but you can have the opposite effect. Someone's getting hit with 1,000 emails per day. They start ignoring them, and that 1,001st is the actual event that they're interested in. So, using the detectors or alerts in observability and the pre-flight checks and configuring them correctly, it's really key to getting the most important alerts through.
Okay. And another area that often crops up, and I'll hear this often, is the sort of privacy and compliance. And how does it contribute to that?
So when you talk about privacy and compliance, obviously the whole platform, has certifications associated with it, that obviously ensure the integrity of the data.
Yeah.
The way that the SaaS platform has been built, we have data residency, for our European customers. They can choose between Dublin, London and Frankfurt.
Okay.
When it comes to things like sensitive data, obviously the customer is ultimately responsible for what they are sending in. But there is capabilities within the OpenTelemetry collector to start, masking data and modifying the data that comes in. So there is the ability, if there is sensitive PII data coming through, you can strip that so it doesn't ultimately end up in the platform. Right. But, again, this is where, during any proof of concept, you would iron this out with obviously test data that, says it's exposing sensitive data, but you would then configure your hotel configuration to be able to handle those kinds of scenarios.
And typically then, and this is another. Do you find are public sector organisations sort of leaning into this as well, or because they've got lots of legacy on-prem capability and lots of complex environments? I mean, what's your experience of their approach to this? Are they interested?
So I've personally not been heavily involved in public sector, but the fact that I've been tasked with building out a demonstration for public sector environments says to me that the company is seeing an uplift and an increase in interest in observability. So,
I guess, and then typically, what are the sort of organisations that you would see that are interested in it? I mean, are we talking financial services? Are we talking manufacturing? OT? What's your sort of experience of those organisations that would look at something like this and would see the real business benefits of what we've already discussed?
Well, I've spoken to customers from all of those different areas. It doesn't necessarily suit a specific industry or otherwise. If you've got a system that's generating logs and metrics and you want to monitor that, Splunk Observability Cloud can do the job for you.
Yeah, so one of the interesting things when it comes to all of this is that, so far we've talked about infrastructure and applications. What is the most interesting thing that comes out of OpenTelemetry is custom metrics and custom, what we call span tags in the APM world.
Called span tags?
Span tags.
Span tags.
Yeah, span tags. So this is the ability to add metadata to your tracing data.
Right, okay.
Custom metrics are absolutely critical because these are non-standard metrics, but these are metrics that are critical to the business.
Yeah.
So we could take, examples like shoes sold per second, ships leaving the dock per day. These are critical.
Or glasses.
Yes.
As in spectacles,
Absolutely,
for example.
Yeah, potentially. Anything that is a custom metric that's a key business, value indicator is absolutely critical, to that business to be able to understand, how that metric is trending.
Yeah.
Okay.
So having the ability to also, not just ingest what we call like standard metrics, your cloud metrics, your host metrics, etc., being able to pull in custom metrics and understand custom data is absolutely critical.
Yeah, because what it can allow you to do is to see where your outages and problems are affecting your business metrics. So taking the example of spectacles, if you are processing and shipping out a number of spectacles per day, it might be very difficult currently to understand if an outage in this server farm is impacting that. If you're ingesting all this stuff into one place, you can start to see where these outages are impacting onto the business metrics.
I see the broader. So what about what trends in observability and monitoring should the audience be aware of? What do this is a space you're both very familiar with. Where do you see it sort of, what areas are trending that you'd like to sort of discuss?
So I think for me, where I sort of like see interest and uptick is around being able to easily identify what is going on. And we have started in the platform to really build on something what we're calling like related content. So that's the ability to be able to, for example, look at some infrastructure, but then in one mouse click, get into the logs for that infrastructure.
Yeah.
So ultimately having that single pane of glass without having to leave that browser tab, you can stay within context all the way through the platform.
Yeah.
I also see a lot of people really pushing the boundaries of the SDKs for instrumentation, really asking for, everything. Ultimately, you can only support so far.
Yeah.
But obviously, like with SPA, single web page applications, we got other challenges and interests around like React-based solutions and stuff like that. So again, constantly striving to be able to provide, capabilities in those areas.
Okay.
One of the other biggest trends is that we know that observability costs money, and it doesn't come cheap. But we are about to release something that we call the metric usage analyzer, which is going to be an extremely welcome addition to the observability suite, because you'll be able to see quickly and easily, the volume of custom metrics coming into the platform. Combining that with the already released NPM tool, which is the metrics pipeline manager, this will allow you to very easily select which metrics you would like to archive or just drop potentially, thus reducing costs.
I was just going to say, I mean, there's a concomitant sort of impact on sort of data usage then, isn't there?
Yeah. So on trends, I can't see the future, but I can tell you what I'm hearing from the people that I'm speaking to about observability. They want to really understand that mystical black box that sits in the corner that provides a business critical function, but it's been built over years out of spaghetti code and no one's quite sure how it still works. If we can implement that, instrument that, and understand how that's working. The other thing which reiterates what Robert said there is fixing things quickly, preventing downtime in the first place. So the ability to have everything in one place, so it genuinely can do from a single tab in your browser. You can go through your application performance monitoring, through to your real user monitoring, to your logs, to all in one place. So you can really get to the root cause of the problem and fix it very quickly. And then add on to that the AI assistant, which I can't reiterate enough how useful it is. When I first saw it, I was like, no way. But genuinely, just ask it what the problem is, and it brings you straight to where it has identified the problem for you.
Fantastic.
So yeah, I see people. They want to get to the root cause quickly so they can fix it, prevent the downtime in the first place.
I guess the last one for me, and I know this is something which you're an expert in, digital experience monitoring, DEM. It strikes me that this sort of capability is sort of front and center in this space, really, because for me, if I go on a banking app, for example, and it's not working, there's a frustration. Whereas if as a sort of organization you've got all of this capability being fed into you all the time about, as you said, application process monitoring, you can see straight away where the problem is, can't you? Presumably, is that right? So the end user is ultimately going to be one of the beneficiaries as well. And does that be fair?
Yeah.
Yeah, I mean, you've got to treat, when it comes to DEM, it's your shop window.
Yeah.
And it doesn't matter what you're in, travel and tourism, e-com, banking, etc. Especially these days, we've now got 5G mobile, we've got gigabits of connectivity back at home, we're not on US robotic startup modems anymore, so people expect a really snappy experience. Also, everybody is striving to be on page one of any search, when it comes to, tools like Google, etc. So search engine optimization, performance, availability, mitigating downtime. Yeah, I mean, you don't want to be on down detector. I mean, that's
helps,
if you ever are experiencing a problem, when you're at home, one of the first places I always go is to down detector to see if there really is a problem. Is it me or is it really down?
Yeah.
And if it is, I shop on a very well-known website that provides free delivery as long as you subscribe to it. And if that's ever down, I don't know what I would do.
Catastrophic.
It would be.
Certainly in my house, it would be.
Yeah,
I can say that.
So digital experience monitoring, that's made up of two tools.
Yep.
One is real user monitoring, and I'll come on to that in a minute. And the other one is synthetic monitoring. Synthetic monitoring is typically monitoring critical user journeys or critical business flows through a given web application. Mm-hmm. For example, it's like go to the homepage, do a search, hit a PLP, a product landing page, add it to the cart and click checkout.
Okay.
Sometimes you can go all the way through, but typically you don't, because otherwise you're putting in credit card details and you're also reducing inventory, which could ultimately lead to the item being out of stock, etc. Or you could choose a dummy product. I mean, I can talk for hours on this topic, so I'll stop there. But coming back to synthetic, it is mimicking those critical user journeys through a web application, using a real browser from key points of presence, in geographies that are important to your business.
Yeah.
Yeah.
They run 24/7.
Yeah, that's what the big why behind synthetic monitoring. They run 24/7. So in your example of your banking app, you would never see the slowdown because it'd get picked up instantly by the synthetic monitoring, and you'd be able to fix it before a real user has to actually experience that.
Real user monitoring, on the other hand, is, as it says, it's real users. Yeah. So what happens is there's a small JavaScript tag is embedded into your web application. You can choose where you want to embed that, on which pages, etc., or you can have it rolled out site-wide. And as users interact with the web application, the browser picks up the JavaScript tag, it compiles it, executes it, and it starts sending data back to Splunk Observability Cloud. Mm-hmm. Within that, we get some really key metrics where we can understand real user performance. And this can highlight, key differences in ISP connectivity within a given region, for example, or the fact that the page is loading really slowly in version X of Y browser on Z operating system. It will give you interesting data in and around that. Obviously, again, it will also highlight you to slowdowns, but hopefully your synthetic testing, as long as you're doing that as well, has already detected that for you as well. The one thing to remember with real user monitoring, it's only any good if users are on your website.
Yeah.
So if you are, for example, like the National Lottery, nobody's going to be buying lottery tickets when the draw closes, and that's when real user traffic would potentially drop off, as an example.
Yeah. On real user monitoring, what's key about that is you can't predict users. So you've got your synthetic monitoring, you've got workflows that you've set up, but users are going to be users, and they're going to do things that you might not expect, things that you might not be able to predict. So that's where real user monitoring comes in. And this gives me a good opportunity to talk about my actual favorite thing in Observability Cloud. So within synthetic monitoring and real user monitoring, there's a film strip playback feature. So you can actually watch in real time that user's journey, where their mouse was, what they're clicking on, where they're navigating to. So you can really understand how your users are interacting with your platform.
And just to close out with the end-to-end visibility, so for every run session that we capture, there's a corresponding APM trace and corresponding logs with that. So you can, from the moment a person starts interacting with your web application, you can see the impact of the data as it flows through the whole Observability Cloud platform.
Yeah.
Well, that's fascinating. I tell you, that genuinely is fascinating. I can just picturing what's going on at home now with people in the sort of back end plotting the journey of various members of my family around various websites, and
your bank account diminishing.
Inevitably. Listen, I'd just like to thank you both for your contributions today. I mean, it's very obvious your enthusiasm, a depth of knowledge on the subject is absolutely phenomenal. I'm very grateful for it, and we'll look forward to working very closely together with our colleagues at Splunk in the coming months and years ahead.
Thank you, John.
Thank you, Robert. You're the real expert.